Two cars are 190 miles apart and they travel towards each other. Is that not a total distance? That's the first thing that catches my attention in this problem. And once I know I'm dealing with a total distance, I want to say rate times time plus rate times time is going to equal 190. This is the distance for one car and the distance for the other car, adding up to a total distance of 190 miles. They meet in 2 hours. One car travels 5 miles an hour slower than the other. Okay, one of them is traveling at R, the other one's traveling at R minus 5 miles per hour. They meet in 2 hours. Nobody had a head start, so they're both traveling for a time of 2. And that's all we need to set up our equation. Now let's do the distribution and see what we have. We have 2r plus 2r minus 10 is equal to 190. We can now combine like terms on the left-hand side. That will give us 4r minus 10 is equal to 190. I will then choose to add 10 to both sides, moving that over to the right-hand side. And so I will have 4r is equal to 200, and therefore dividing each side by 4, we have r is equal to 50 miles per hour. Now that is one of the speeds, and it says what are the speeds of both cars? Well, one of the speeds was r, the other was r minus 5. So let's subtract 5 to get 45 miles per hour for that second vehicle, and that's what we're looking for. This problem is a little bit different and it doesn't show up very often, but I'd like to do it for you to show you some of the tricks that can show up. Two canoes travel down a river starting at 9 o'clock. One canoe travels twice as fast as the other. After 3.5 hours, the canoes are 5.25 miles apart. This is not a total distance, but a distance they are apart. One is traveling faster than the other. Here's the other one. They're traveling in the same direction. And what we have here is how far apart they are after those 3.5 hours. So this is actually a difference in their distances is 5.25 miles. And therefore, we're going to have distance for one minus distance for the other is equal to 5.25. Now one of them is traveling twice as fast as the other, so its rate will be 2r, and the other one will have a speed of r. And as far as time goes, we have a 9 o'clock start time, which is extra information there only to confuse you. And both of them are traveling for 3.5 hours, and no one had a head start. So let's substitute in 3.5 for the time on each of these vehicles or canoes. And let's see what we have. 2 times 3.5 is 7r minus 3.5r is equal to 5.25. And combining like terms on the left, we have 3.5r is equal to 5.25. Let me slide that up there. Dividing each side by 3.5, we can now find out that r is equal to 1.5 miles per hour. And the problem wants the rate of each canoe. The other one's going twice as fast, 2r, which will be 3 miles per hour. We don't see this pattern very often, but it does show up. Usually it's RT plus RT equals D for a total distance, or RT equals RT when you have the same distance, but every once in a while, like in this problem, we have plus or minus. When the distance apart is given, we're going to subtract instead of add and have RT minus RT is equal to D.